This conference will now be recorded.
Good afternoon, folks. I'm Maurice McHugh, the Future Capabilities Lead for GOES-R, and welcome to the Satellite Book Club session number 182. Today's presentation is GeoXO Sounder, GXS, an introduction and potential uses. Our wonderful presenters are Frank Alsheimer, Science and Operations Officer from Weather Service, WFO Columbia, South Carolina, and Tim Schmidt from NESIS STAR. Our facilitator is Doug Kahn, meteorologist at NWS WFO Cleveland, Ohio. Just before we get going, quick reminders that the session is being recorded. You should have heard that announcement a minute ago. The Q&A will be after the presentation, and I strongly encourage attendees to post their questions in the chat room so that we can field them through there. Please also sign in with your full names or specify your full names when asking a question in the chat. And we're also looking for future presenters for future satellite book clubs. Please get in touch with our Tower S team of Kashad Bowman and Emily Maddox. The training team can also help create training materials that may be currently unavailable. Contact Ross Van Til for information or questions regarding that. A few thank yous here. I want to articulate some huge thank yous to our Tower S team of Kashad Bowman, Emily Maddox, folks at OCLO, GOES-R, JPSS, and our facilitator today, Doug Kahn. Starting to the bios for our presenters, Frank and Tim. Frank Alsheimer is the Science and Operations Officer in Columbia, South Carolina, the WFO there. He's been with the Weather Service for 32 years, including the last 19 as SU. He was heavily involved in GOES-R series training and user readiness as part of a variety of satellite teams, and is currently a member of the GEO-XO GXS Sounder Science and Applications Working Group. Easy to say. Tim Schmidt works in the Sensors and Calibration branch within the NESIS Center for Satellite Applications and Research, also known as STAR, located in Madison, Wisconsin. Tim has experience with all our nation's geostationary sounders, the VAS, first in GOES-4, and the sounder in GOES-8 through 15. Tim has published over 100 journal articles, several book chapters, and co-edited a book all associated with some aspects of GOES. Tim received his master's degree from the University of Madison, Wisconsin. Frank and Tim, welcome to the book club, and we'll hand it over to you.
All right, thank you all, and a belated astronomical spring. So thanks to all the co-authors and people that we haven't listed. So we'll start with a little bit of history. Back in 1985, a guy named Vern Sumi said, hey, we should get increased spectral resolution in infrared for an improved vertical resolution. So we're here to make that happen. Looking way back, as was mentioned on GOES-4, there was a visitor atmospheric sounder, and that had 12 channels. Experimental instrument that improved to an operational instrument, but still low spectral resolution, 18 channels on GOES-8, and then the GOES to GOES-15. But again, what we're here to talk about is the huge improvement with the GeoXO Sounder, slated for launch in 2035, not 12, not 18, but on the order of 2,500 channels. So, and again, if you have any other history of the other near misses between this, ask me in the question and answer period. I spent about half of my career telling people how good ABI was going to be. You've probably heard better, 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 spatial spectral temporal, 3, 4, 5. I think that panned out. On the GEO Sounder side, if you look at everything we did with the old GOES Sounder that we had in GEO, that's defined as 111. Now the improvement factors to go to GXS is something like 4 times the vertical resolution, 5 times the spatial resolution, and 10 times the temporal resolution. So I would say even better, better, better. If you're interested in just the overall GeoXO, Pam Sullivan gave a nice satellite book club a bit ago. Of course, here today we'll talk about the hyperspectral infrared sounder. Last fall, Ball Aerospace was selected to be the vendor. So this is really just the beginning of this whole process. Lot of uses, and you hear about them today, be it on the numerical weather prediction side or the nowcasting side. We won't talk much about air quality monitoring of the GXS. You know this better than I. You know, radiosondes are great. They're in situ, but mostly over land and twice a day. Aircraft have some moisture, but mostly during the day and only at select airports. You know, LEO is great for global monitoring, but again, you don't have a high temporal resolution, and right now it's relatively coarse spatial resolution, and that's where the GXS comes in. You know, rapid imagery over the area where we live. Maybe too much on this slide. Ideally, we'd have an east and a west sounder coverage, but one is way more than none. So again, this is slated to be at approximately 105, a central location. A real key here is the spatial resolution. You know, when you get down to this 4 kilometers, now you can see between a lot more clouds that you couldn't do if you had, for example, a 14-kilometer field of view. So that not only gives you finer moisture gradients that you can see, but also more of them, maybe even soundings in the eyes of hurricanes. So spectrally, if you look at the bottom there, the red bars, that's what we'll get with a GeoXO imager or GXI. And that's good. Imagers are great, but they average over important vertical spectral information. So the green is part of the spectrum that we'll get from GXS. And you can see it's got the 2 broad regions, long wave, region, something like, you know, 9 to, you know, 14.7 wavelengths, and then what we'll call a mid-wave IR. So again, something like, you know, 4.5 to 6. So you can see we're on the shortwave side of the water vapor continuum. Well, there actually be one new GXS image as well. And again, fine spectral resolution, which leads to this fine vertical resolution. There's actually a simulated image for simulating GXX, and you can see just in this one box here, a couple different locations and the corresponding spectra here. So just looking at the spectra, you can see a cloud, cold, thick cloud, you know, the clear, and some affected by clouds of different thicknesses. So again, there's a lot to be had even just by looking at the spectra. So as I said, Ball is the vendor here. It basically take this slit as you move across, building the full disk in these 5 swaths. So this is similar to, for example, the ABI takes 22 swaths to cover a full disk. This will do it basically in 5 swaths. And you can see we have a total of something like 1,500 channels, spectral channels, as opposed to, as I say, 18 on our previous GOES imager. And this whole, you know, can be done in a half an hour if you just scan in this scenario. So here's a concept anyways of how we would do that. So again, swath 1, swath 2, swath 3, straddling the equator there, swath 4, and finally swath 5. So again, this is simulated data showing one spectral band out of the 2,500. And again, you could do this all in approximately 30 minutes. How exactly it'll be scanned is up in the air. One idea is maybe we do swaths 1, 2, and 3, and then 4, then 1, 2, 3, 5, and hence get higher temporal resolution to support more winds in the northern part than in the southern part of the disk. There's also this concept right now mesoscale scans, at least sized, are to be 1,000 by 1,000, but you can see the swath is much bigger than that. So maybe their idea is that we could do a mesoscale even larger. These just show an example of 2,000 by 2,000. And then, of course, if those are interspersed, you can get improved spatial or temporal resolutions. So kind of, you know, so spectrally, this is what we've seen, the red versus the green. The GXS would have one in the center of the country. And of course, GXI would cover, you know, with the two on the wings. So I guess we'll have opportunities to put that data together. You've seen water vapor weighting functions or contributions functions for like a water vapor channel, but here they are not only for temperature and moisture, but also some other gases, for example, like ozone, etc. So you can see how, you know, you get a lot of channels and how they vary and cover different parts of the atmosphere. And of course, that's what allows you to do an inversion to make an estimate of temperature and moisture profiles. As far as information content, if you compare, for example, moisture, what we're getting today, it's something like 2.5 vertical pieces of independent information, but that increases to something like 11, depends on the atmosphere, etc. Even more times in thin clouds. So again, what we're missing today is that vertical information, and this will give it to you in clear skies. There's been a lot of work on this case, everything simulated. So an Aussie, where you've predefined the truth when this hurricane in the simulated environment is the black line, and then you can see the forecast without GXS, got off on the wrong foot, never got corrected. The GXX forecast is much closer. And again, this is, we've defined the truth, so we know what it is here. So again, the improvement for hurricane tracks and intensity. You might say, well, that's simulated. Here's another example using the same model, showing how if you just look at the CONUS region, the GXX ranks as the highest contributor to the NWP over that area, and that's because you get multiple looks. And this is just assuming a 1 hour cadence over the disk, as opposed to something finer that we might be able to do. So I like to think of this as the floor, not the ceiling. There is a hyperspectral sounder up there right now, operated by China. And here's an example of a Typhoon Maria. When you put in more data every 3 hours or 1 hour or even 15 minutes, you get improved track forecasts. There's also improved intensity as well. So again, we'll improve hurricane forecasts, intensities, and tracks. And now Frank will take over for the WFO perspective.
Yeah, thank you, Tim. I appreciate all the information you gave on the satellite and the new instrument that will be coming our way. But how do we translate that into actual information that we can use at the forecast office level? Now, obviously, we're undergoing a transformation right now within the Weather Service as to exactly what we'll be doing over the next 5 to 10 years, but we are still going to be heavily concentrating on probabilistic IDSS and moving towards community-centric type of warning. So beyond the polygon, if you will, and beyond the watch box, providing additional information to those core partners so they can take appropriate actions. So let's take a look at some of the applications that this information is going to have. Obviously, one of the big ones is the near storm mesoscale analysis. Be able to look at what's happening in a much shorter time frame at much more levels of the atmosphere. We'll be able to compare it to high-res model forecasts to see where we're on target and where we're going astray. The facets TIM concept of where we can really provide nearly constant updates to the users. Again, not just the warning or the watch. Information will also help us with precipitation type, especially in the weather, in the winter, along with the wind and moisture profiles. Wind surges and low-level RH information to help us with fire weather and spot forecast type of things. Aviation forecasts, maybe not as much at the WFO level for icing or convective turbulence, but certainly information that could be useful in terms of airport operations. Air quality, physical modeling. I mean, this is a lot more information that we can start putting into our models, including the regional models. Machine learning, which we're just starting to tap. There's going to be tons of opportunity to train on data, and as we get more of this data from GXS, that means our uh, analyses will be better, which is essentially what a lot of this machine learning trains on. And then, of course, flash floods. I'll move to the next slide. Okay, here's an Aussie simulation where we've used a machine learning retrieval approach for simulated information. On here, the black lines represent the true and the red and green lines represent the predicted with the information added in from the sounder. And you can see how well that this, there's still obviously little wiggles and things that you're not totally catching. But it really does a good job at simulating the approximate atmosphere as we move forward. If you look closely, these are every 15 minutes, so you can really see changing pretty much right before your eyes as the atmosphere adjusts. Next slide. So what I'm going to do is kind of run through what maybe it would look like for a severe convective event, how this new instrument would impact pretty much everybody in the forecast office during it. Of course, a couple days before the event, you're in an enhanced risk, you're concerned about things, so you start making staffing, and then you send out one-pagers and schedule webinars with your core partners as necessary. And so the GXS role here is obviously the input that goes into the models would ideally improve the areas that you can concentrate on for the worst of the potential weather. And you can also watch upstream trends, especially, in my neck of the woods in the southeast. Usually you can see these systems moving in from the west the day before, and to watch how well the models are handling that and comparing it to the actual observations. So next slide. Once we get to the day of the event, you have, of course, your morning briefing where a lot of information is passed on. And again, this is when you can start to look at, see, hey, where am I seeing some differences from the models based on the GXS additional information? So you can compare model soundings to soundings from the GXS or GXS enhanced, and follow your critical layer of temperature and moisture fields and so on. If we go to the next slide, I think we have an example here. Yeah, here's an example of what simulated GXS retrievals would look like. This is showing theta from 500 to 850 millibars using a model simulation deep neural network model. And you can really notice how in this case the convection fires on those gradients of the color representing those theta E difference values. So this, again, every 15 minutes you're seeing data there. So that's the kind of information that you would have potentially have as we get GXS actual data in. Be able to use this for lots of, convective initiation, being able to tell your folks maybe 1 to 3 hours ahead of time if the models are doing well, where you can predict maybe the convection moving and forming over time. Next slide. So once you get to the hours before the event, you're staffing up everybody in your office, notifying, of course, the management, and getting pretty much everybody situated so that they can get ready for the big event. So your GXS is giving you some additional temperature and moisture trends going on. Its data could be assimilated and update maybe some of the high res and convective allowing models and ensembles, things like the WAFs or other systems that are similar to that. And then, of course, information for some of your machine learning products the input in there may be able to improve those, especially considering we're looking 10 years down the line before we actually see this live data. Next. I'm going to let you explain this slide a little bit, Tim.
All right. So again, this is a simulation. And again, these are the temperature and moisture profiles that went in and were used in a forward calculation to calculate what the radiances would be. And then that's what you see here on the left, for one of the spectral bands of the radiances over time. But at this one spot in Wyoming, now we're looking at the spectra as it changes over time. And these absorption features, you often are colder than the base temperature or the mean value in here, and that's because the atmosphere is getting colder with height. But when an inversion sets up, these spikes, if you will, now poke up like they do here, versus what they do here. So again, the high temporal resolution with the high spectral resolution, even without any numerical model, without anything, you can just look at this spectra, for example, in certain situations, say, oh, there's inversion, and maybe get some estimate of, how fast it's breaking down.
Thanks, Tim. Glad you explained that one. All right. Obviously, there are other positions in the forecast office when it really starts to get active. You always need to have a communicator and a coordinator going on. And while they probably won't directly be using the GXS information, certainly derived products that come from the information, loops, things that can keep the communicator situationally aware within the office. Next slide. The warning operator, generally we don't want the warning operator doing a whole lot other than looking at the radar and making the warning decisions. Of course, how those decisions and what those warnings look like in the future is yet to be determined. They may well not be the same type of warning that we're used to issuing today. But the GXS could definitely have a role in derived products, as an example, prob severe input that a lot of folks use to overlay on their radar when they're making those decisions. So even though the warning operator is mainly concentrating on the radar, these additional products that help out will be enhanced as we get GXS data into them. Next slide. Social media. Certainly right now, this is one of the bigger ways that we can get information out through the social media or the NWS chat to our partners in real time to kind of fill that watch to warning gap. So we can make graphics with the information. We can give guidance to folks in the media who might be doing that, looking at, all right, here's what we're looking at now. And of course, creating graphics using the information for social media. So even the social media NWS chat person or whatever that looks like in the future will be using that information to communicate. Next slide. Of course, the mesoanalysis, you probably knew I was going to bring this up. The role for the mesoanalysis is probably the biggest role with the information from the GXS. You'll be able to monitor all the trends of temperature, moisture, loft, kind of like what you do with new caps right now, but in a much more temporal frequent set of observations. Again, comparing it to the short-term model guidance, and again, derived products. Well, another example is the lightning cast. And this is a person who really can also communicate with folks if they're have specific events that they need individual DSS for. So next slide. Of course, one of the things I think we've all learned over time is that severe weather often also comes with flash flooding. And so we, in our office, we'll have somebody dedicated to that. And GXS will have a big role in helping that out with moisture transport, looking at low to mid-level boundaries, of course, improve modeling, and then more derived products, things such as CAPE and TPW that can help with that. And next slide. Fire weather. While a lot of times, if you got severe weather going on, you're not quite as concerned about fire weather. That's not always necessarily the case. They can both happen at the same time. So it'll help you determine with the wind surges, low level and mid level RH, mixing height levels with some smoke transport potential. So a lot of things that can be used for fire weather as well. Next slide. And aviation. I know we're running out of time here, but certainly this will also help us play a role with the aviation icing levels like we find in new caps, convective turbulence, lightning initiation, supporting airport weather warnings and amendments to TAFs and so on. So next slide.
All right, so this is what we're not talking about. We're not talking about trace gases, but obviously you see the spectra. GXS can help the atmosphere composition by seeing some of the same things during the night or even some new phenomena. So thanks to Dylan Monet from the University of Minnesota for this. So, you know, images are great, but they average out vertical important information. LEO's great, but it lacks the time resolution that's needed. You know, GXS will help in the nowcasting and numerical prediction, both on the full disk and regional models. It also help improve other derived products. For example, if you had an imager only cloud property, the GXS will help, especially, for example, in thin clouds. A lot of opportunities for new areas. There's been an economic assessment and literally billions in benefits, and this is part of the critical component of the global constellation of advanced sounders. As far as GXX plans, the most important thing is lower right here, satellite book club on the GXS. So I'll just leave it with some more information here and turn it back over. Thank you.
All right. Thanks, Tim and Frank. Great talk, and certainly a lot to look forward to over the coming years. So we encourage everybody to stay on for the discussion, especially those from field forecast offices and those from regional headquarters. And if you have a question, please specify your full name in the chat. And Emily Maddox will be posting a link for anybody interested in participating or even facilitating future satellite book clubs. So please fill out that short form if you're interested. All right, and then in a week from today, we'll have another satellite book club session, Thursday, March 28th at 12 p.m. Eastern Time. Eric Houlihan and Leanne Simpson from UCAR will discuss monitoring harmful algal blooms and sargassum with satellite products. Should be an interesting talk. And then we finally encourage attendees to contact the TowerS team, Kashad Bowman and Emily Maddox, for any questions regarding the Satellite Book Club or for any configuration of satellite products. All right, let's look at some of these questions from the chat. Looks like Scott has a statement here linking to one of the satellite blogs, sounding in the eye of a tropical cyclone. Looks like from 2018. He knows it would be a lot more common with 4-kilometer resolution from the GXS.
Yeah, certainly for two reasons. One, because you have the finer spatial resolution, but then you have multiple looks at it, especially, for example, if we had a meso that we could look in between the swaths.
All right, and then we also have a question from Steve Goodman. He says, how low in the atmosphere might the GXS or GXS ML or GXS forecaster in the loop be able to resolve the height of the PBL? The SKUT example showed a lowest level of 800.
Yeah, that's a great question. We're really just starting with some of this machine learning things. We'll find out. I think I'm optimistic we'll be able to go lower than that, at least in a uh, evolution approach. Maybe you don't exactly know how high it is, but you can see it's lowering or something like that, or how it changes spatially.
All right, thanks for that. Another question here from Dave Zaff. He asks, how might soundings look when compared to today's NewCap soundings? So I
Yeah.
assume kind of in the vertical resolution there.
Yep. I guess first of all, hopefully we'll do, today, for example, you look in AWIPS, you can go and see, the ABI alone over there with one air characteristics and temporal and spatial resolution, and then new caps over here with another. Hopefully by the mid 2030s, what we're really doing is fusing these together. And what you'll see is just the best estimate of the atmosphere that we can get from satellite. So that would be combined with the microwave from the polar when we have it, geo hyperspectral sounder when we have it, and then even an ABI to get at finer resolution, kind of what's done today with a polar hyperspectral combination. So I guess in clear skies, I think these should be relatively similar. Of course, NewCaps uses the microwave and can give you a profile in thick cloud. There's, I think, reason for both of them, like I say, due to the, finer spatial resolution that the GXS and temporal resolution will allow.
All right, thanks for your response there. I have one question for myself here. I guess it's to either of you, but how do you see these improved satellite soundings being implemented into operations? I guess so. Do you
We'll let,
envision that the? Oh, sorry.
I was
Do
going to
you
say,
envision that the
Frank,
GXS?
go ahead.
Oh, do you envision that the GXS data is more in the background, feeding into some of these real-time models like the WAFs versus direct human interpretation?
Yeah, I'll let Frank
Yeah,
take a first cut at that.
yeah. Generally, I would say that it would be ideal to be both, so that we can bring the data into the modeling systems. And I imagine 10 years from now, we'll be we'll be able to run hourly models on our iPhones or things, something along those lines. It might be a bit optimistic, but certainly to be able to bring that data in. I think the WAFs, for instance, has um, shown how good you can get when you are able to bring your radar data into the modeling process. So more good data is always going to be a good thing. But I think it's also going to be very helpful to the meso analyst to be able to have really short time steps for that additional information, not just what we're used to looking at for a surface ob, but in many layers. And I know, for instance, here it can, especially if you have a high cape situation, you can go from not much to a thunderstorm really quickly. And you can miss that if you're looking at hourly data. Whereas if we're having data every 20 minutes that we can look at, I think that's really helpful in terms of the mesoanalysis side of things. So my answer would be both.
All right, yeah, thanks for that. Just a couple more questions here, it looks like, from the chat. From Ryan Kramer, hyperspectral infrared sounders like AIRS and CRIS are fundamental to climate research and important for climate model evaluation. Have you considered how GXS may be used by the climate community and what that interaction could look like?
Yeah, I think that's why it's important that we hold up our part of the global tent, if you will, with a ring of these goes hyperspectral sounders around the world. EUMETSAT is launching theirs you know, hyperspectral maybe next year. Japan's under contract for one as well. You know, the real thing that these will add is that the diurnal signature of the whatever phenomena you're looking at. So for example, you know, moisture or clouds, you know, things in the vertical. So I think there will be a lot of climate applications similar to what's being done, like you say, with AIRS, IOSI, and CRIS, but being able to extend that with better time resolution throughout the day.
And we have a question from Jim Yo. What can you say about the potential synergy of the sounder and the AC instrument on the same platform?
Yep. Yeah. So the atmospheric composition would also be in the center. So that's basically a UV vis. So that's great for what it measures during the day. But for example, if you need to constrain that at night, you, for example, can use you know, ozone estimate from the GXS during the night. So when the sunrise comes up, you can hit the ground running, if you will. So I think there will be constituents that GXS will be able to help the ACX, and then again, more research is needed, but also things that the GXX sees that the ACX can't. So I think together, being on the same platform is going to be very, very powerful for, you know, air quality, human health, etc.
All right, a lot of great discussion here. Looks like we have one more follow-up to Dave Zaff's earlier question about NewCap soundings. This is from Scott Lindstrom. How many pieces of vertical information will exist from GXS? The LAT profiles have around 3 pieces of information for moisture. NewCaps has around 6 to 10 for temperature, 4 to 6 for moisture. So what will GXS offer?
Yeah, of course, it depends on if you're talking about clear sky or partly cloudy sky. So here was an estimate, you know, of something like 11 for moisture and something like 13 for temperature. But that goes up. Again, it depends on, you know, the atmosphere you're looking for, how dry it is or not. But if I had to give one number, I'd say 12 vertical piece of information. But again, that's compared to what we're trying to eke out with ABI today, which is more like 2.
All right, perfect. Well, I don't see any more questions from the chat. I guess I'll just end it here with a statement. Just being in a Great Lakes office here, I'll be interested to see how this can improve upon not only the convective forecasting, but also lake effect snow forecasting, especially the upstream moisture connections to the other Great Lakes. So that'll be something I'll be looking forward to over the next couple decades.
Yep, agreed.
All right. Well, I think we're good on the questions here, and I can turn it back to Morris for the final remarks and to promote the Slack channel. Take it away.
Thanks, Doug. So I just want to thank everyone for their for being here today, for your attendance. I want to thank our presenters for an awesome presentation, and also to thank Doug for facilitating so well. Hopefully we'll see you all back in the next time around at the Satellite Book Club. Thank you all.